Alright guys, so today we're going to look at actually applying our skills that we've learnt with factorization and look at applications of quadratic equations. So we can really use quadratic equations when we have equations that are equal to 0. So for example, m times by n is equal to 0. So if we know this equation, that would imply that either m would have to be equal to 0 for that equation to hold, or n would have to equal 0. So that's a basic rule of maths. Okay, so looking at a binomial here, we've got x minus 3 times by x plus 2 is equal to 0. This implies that either the first term, x minus 3, would have to equal 0 for that to hold, or x plus 2 would have to equal 0 for this equation up here to hold. So therefore, x would either equal to 3, or x would equal to minus 2 for that equation to hold. Either of those values of x would be solved for x here. Okay? So let's look at another example. Find x if x squared minus 4x is equal to negative 4. So maybe have a crack at these yourself. All right, so if I was looking at this straight away, I'd immediately think, all right, we've got a common factor here. So I'd pull x out the front of x minus 4 is equal to negative 4. Now this doesn't help us because that's not equal to 0. So x could equal a whole range of things. We couldn't just write x is equal to minus 4 or x minus 4 is equal to minus 4 because there's a whole range of things that x could equal there. So that is wrong. What you would need to do is get everything over to one side so you get the equation equal to 0. So you'd add 4 to both sides. And now you're cooking with fire because you've got this equal to 0 term here. And we know we've got a quadratic, so we can factorize. So what adds to give negative 4 and multiplies to give positive 4. So x minus 2 times by x minus 2, or negative 2 times a negative 2 is equal to positive 4. And negative 2 plus negative 2 is equal to negative 4, okay? So therefore, in this case, x minus 2 would have to be equal to 0 for this to hold. So x would be equal to 2. So this is a unique scenario where x, in a quadratic, where x can only be equal to one thing there. Okay, so let's look at another word question. So a formula is given. X outside of x plus 14 divided by 2 is equal to y. If y is equal to 16, find all possible values for x. X must be positive. So that's just something to note for the end of the equation. So first off, if given you an equation, you'd substitute in. So you've got x outside of x plus 14 all over 2 is equal to 16. Okay, so you want to get rid of fractions. We don't like fractions, so you'd multiply by 2. So you've got x outside of x plus 14 is equal to 32. All right, next thing, you don't want brackets because you want to be able to solve this. So you'd expand out. X squared plus 14x is equal to 32. So we know we've got a quadratic here, so it's not going to be a simple case of getting x by itself. So we need to make this whole equation equal to 0. So we could do that by taking 32 away. X squared plus 14x minus 32 is equal to 0. Now I've got that. We can look at what adds to give 14x and 14 and multiplies to give negative 32. So it's going to be a positive and negative number. See if you can figure that out first. So maybe pause it here. Try and solve it from here. All right, so what adds to give 14 and multiplies to give negative 32? Negative 32 and positive 2 multiply together to negative 32, and they would add to give negative 14. So you've got x plus 16, so x minus 2 is equal to 0. You can check that if that answer is correct by expanding back out and see if you get there. So from here, either x plus 16 is equal to 0, or x minus 2 is equal to 0. So x could be equal to negative 16, or x could be equal to 2. However, going back up to the question, it says, find all possible values for x where x must be positive. So here, x must be positive. So that cancels out x is equal to negative 16. Therefore, x would equal to 2 for this equation to hold. So there's a number of ways that you can, so the key steps here, guys, is to try and get this quadratic equation and get it equal to 0. Once you've done that, it's just a matter of factorization. Have a look at example 20 to help you.